Hi there, and welcome to Mr. Morgan's Math Help for Algebra 1. This is going to be the Open Up curriculum here, so make sure you're using the right video lesson to go with your homework. All right, well, for this curriculum here, what we're going to be doing is primarily looking at the homework or homework solutions. You're in high school now, so hopefully you've gotten a good lesson from your teacher. And the idea here is that, as always, the first thing I want you to do is for you to do your homework as assigned, do your best on that, see how you do with it, and then really come back here to then watch the video solutions to check your understanding. That's the idea. So the idea isn't here just to get the answers and move on. It's for you to try it and then come back to this place so you can see, are you getting it, and what other questions might you have, so that you feel more confident going into class the next day, and also so you might have some better questions to ask your teacher when you do go to class. All right, so let's get started with today's lesson, which again today is on the checkerboard patterns, looking at sequences today. All right, so for the first question, we have to evaluate each of the expressions below using the given value. So what we're going to be looking at here is taking the value of n that's provided here. So in this case, n equals 12. And we're going to use that value and put that into the expression. Just recall that it is an expression because it doesn't have an equal sign or something along those lines. If it had an equal sign, we would call that an equation. So for this one here, we're going to take the 3 and we're going to substitute the 3 with the 12. When numbers are joined together, they're multiplied. And then we have plus 7. So in this case here, 3 times 12 is going to be 36 plus 7 equals 43. All right, let's take a look at number 2. So if we take the 4, we're going to plug that in right there. So we're going to have 4 squared minus 3. 4 squared is 16. 16 minus 3 is equal to 13. All right, next one we have t equals 20. So we're going to say 5 times the quantity 20 minus 9 plus 12. So you want to do what's in the parentheses first. So this part here, we do that first. So we have 5 times 20 minus 9 is 11 plus 12. 5 times 11 is 55 plus 12. And so our answer for number 3 is 67. Our next one, we'll take the 5. Again, put it right there. The x is going to be. So we end up with really 2 times 5 plus 13 over 3. So that's the same as 2 times 18 over 3. All right. And 2 times 18 is going to be 36 over 3. And 36 divided by 3 is equal to 12. All right. Got the idea there? Doing okay? Okay, so on our next one, we're going to take the 5 and put it in here. So we have 3 times 6 times 5 minus 17. All right, so 6 times 5 is 30. So it's 3 times 30 minus 17. 30 minus 17 is going to be 13. So we really have 3 times 13, which equals 39. And our last one, we're going to put the 15 in there. So we have 2 times 15 over 3 plus 13. Well, 2 times 15 is 30. So we have 30 over 3 plus 13. 30 over 3 is 10. So we have 10 plus 13, which equals 23. All right, so that's what we have for this first one. All right, hope that helps there. And again, I'm doing a lot today. Most days I may not do all the problems because, again, with something like this, we should be catching on. I'm trying to show you how this works more than giving you all the solutions. So as we move along, there'll be times where maybe I'll just be doing the odd problems and not the evens because it's the same process. All right, let's take a look then at the next question. Next question. This is more what the lesson was like today. Okay, so here we go. It says for each set of figures, show how the green colored tiles in the border can be grouped to allow for quick calculation. Each set of figures has two figures of different sizes for you to work with. Use different grouping methods on each, provide a mathematical expression that connects with your grouping methods. Okay, so we're looking for how we can look at the green colored tiles and group them together. And it does want us to look at, because there's two figures, to have a different grouping method as we do this here. So you can see with A, we have a figure with a size 3. And then when we move over here with C, we have a figure with a size 4. So those are the two figures for this first one. And they do want us to have two different mathematical expressions for the two different grouping methods. It might be easier sometimes though, and I may do it on this one, just to have one, just to show you so you can see the difference. Okay, but for now, here we go. How do you want to group these up? Well, one way you might group them up is you might look at your greens here on the outside, and we can make a group of green right here, kind of starting from an end point, but not taking both ends. And we can have a group there, and a group there. So in doing this, what I have is I have 3 groups, and each group has 1, 2, 3, 4, 5, right? 5 green rectangles. So that becomes an expression. Of course, that is just what the number is, 3 times 5. So we know that's how that works. But an expression, I want to kind of turn that into some sort of a variable. I want to use a variable if possible so that I can use this expression in order to find out other values of other groups, other figures. So in this case here, let's take a look at what I have. It says the figure is a size 3. So this 3 is going to remain the same because I have 3 groups, right? That's going to stay the same. But what's not going to stay the same as this inside part gets larger, because the inside part can get larger with time, right? It's a 3 by 3 triangle, and that's why it's a size 3, because that's 1, 2, 3, like that. The other part is going to possibly change. This part stays the same, and the outside part is a changing part. So it won't always be 5. So in terms of what this can be as an expression, we want to make the 5 into something that can be changed as the group changes and as a variable. So we know at the outside, we're always going to have 3 in this case here. That is the size of the group, or the number of groups I have, 3 groups. And in this case here, when I think about 3 and the 5, what I have is I have the size of the group, which is 3, plus 2. So as an expression, one way of writing this here is I could say it's 3 times the quantity of the size plus 2. Okay, so that's what I want to use for this one here. All right, that's my first expression. Now, let's take that expression here. All right, I think I can do this. Let's try this. I haven't done this before. I think I can circle that. Ah, that's interesting. Let's see if we go to the next page. No, nothing. Thought maybe I could. Well, that's okay. All right, so let's go to the next one. So let's use the same grouping method real quick. I know it wants to use a different one, but for now, I'm gonna use the same grouping method. I had 3 times s plus 2. I'll make a little note of that right here. I had 3 times the size plus 2 was the expression I used. So in this case, if I use the same grouping method, first of all, I have that one, I have that one, and I have that one. And if I use 3 times s plus 2, I can figure out what that's going to be. For like question E wants to know the size of a figure 8. And you can see in this case here, nothing's really changing. I still have 3 groups, and in this case, if I just check it out, the size of this one is 4. Let's pretend we use that one real quick. 3 times 4 plus 2, right? That becomes 3 times 6. And we saw before, this middle number was 5 last time because that was the number inside of our groups. Well, 1, 2, 3, 4, 5, 6, that does match. So this same expression is working for us, okay? So we could use that expression there to help us figure out a size 8. Now, for the homework, though, it did say, well, let's do one that's going to be a different size, a different grouping. So another grouping you could use is you could use something like, let's take all the ones that are touching the blue like this. Let's take all the ones touching the blue over here like this and like this. And then we have our end ones here. So if you looked at something along these lines, what you would say is, well, I have 3 groups in this case here, and they're 1, 2, 3, 4, 5. So that is the size plus 1, and then we're adding 3 more points. So that's another expression you could come up with if you grouped it this way. If you grouped it with the 3 sides and the 3 endpoints. Okay, so both of these are acceptable. Both of these would actually work to help us find a group with a size of 8. They both be fine. For the group of size 8, I'm going to go ahead and use the 3 times s plus 2. So we'll plug in the size is 8. And we have 3 times 10. And we end up with 30. So with the group size 8, we should have about 30 in that case there, okay? Does it work for this one as well? Let's take a look here. If I did 3 times 8 plus 1 plus 3, that becomes 3 times 9 plus 3, which is 27 plus 3, which is also 30. So both expressions actually work just fine, right? And you end up with the same response. F. Turn one of your expressions into an equation that can be used to find the figure size for a shape with 72 colored green tiles. Meaning they're giving us the solution, 72, and we want to turn one of our expressions into an equation. And we said an equation is going to have an equal sign. So to do that, what we do is we take one of the expressions, 3 times s plus 2, or you could use another one, and we set it equal to 72. Now in doing that then, what we could do is we could solve and find out, well, what could that be, and find out what would be the figure size, right? The figure size is going to be s, and you could solve for that if you chose to do that. Okay, so that's one example there. In our second one here, we'll look at kind of our grouping methods here. So same thing, grouping method. We can look and say, well, one thing we could look at this one, we could have 3 there, 3 there, and 3 there. Our grouping method could be 3. That's our groups times something else. Now we don't want to just have the number 3 there. We want the number 3 to relate to the figure size. Well, in this case, we would say, well, that looks like it's going to be our number, or our size, which was 1, plus 2, to come up with that number 3. Okay, so our mathematical expression could be 3 times s plus 2. That could work, right? In this case here, it's one option. Okay, so let's look at another option. Let's look at a little bit bigger one. Okay, when I look at this one, if I did, let's do it real quick. If I use the same strategies as before, on the sides, I have a side, I have a side, I have a side, but then I have these extra ones, don't I, right? I have this guy here, this guy here, this guy here. So the grouping didn't quite work out the same, did it? Right? It's a little bit different than it was last time. So now I'm like, gotta think this through. I do have 3 groups, first of all, for my expression, and I have 1, 2, 3, 4 in each group. So that's like the size plus 2. That takes care of that part. But then I also have to add these other ones, which is going to be, I have 3 of them, so that's the size plus 1. Okay, so that becomes another group. Okay, now is that going to be right? Does that always work? It's hard to say. In this case here, if the figure was size 2, let's just see if it worked real quick. I would do 3 times 2 plus 2 plus 2 plus 1. That becomes 4, so 3 times 4 plus 3, so 12 plus 3 and 15. Well, did I have 15 of these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that does work okay there. So it is working here. If I want to find one with the number of tiles that it's 11, well, then I would take that same equation, 3 times 11 plus 2 plus 11 plus 1. And we're going to have this be 3 times 13 plus 11 plus 1 is 12. So we have 39 plus 12. Is that right? Oops, not sure what that thing is right there. Sorry. And in this case, we would have 9, 3. We're going to have 51. Okay. So the question is that accurate? Is that going to work? Hard to say. It might for that grouping strategy. It's possible. Yeah. Yeah. So it might. 39 plus 12. Here's what's interesting is I did a different one in my notes where I said, well, let's take a look at a different way of grouping these. And in my previous grouping, what I did is I said, well, let's group it this way. I grouped it like this. We'll make a different color. I went with the tops were 3, sides, and then I went with these little chunks of 2. Okay? So in doing that, what I have in that grouping is I have 3, and my size is 2. So let's look at this one here. That's going to be the size plus 1. Then I have 3 groups over here, which is 3 times, 3, sorry, it's early in the morning. In that case here, it just is the size. There you go. All right, so 3 and 3. And in doing that, if I was to plug this 11 in here, I get a different solution. So let's see what's going on. I have 11 plus 1 plus 3 times 11. That becomes 3 times 12 plus 33, which is 36 plus 33, which is going to be 69. Now that's not matching that. So something is a little off over here. So let's take a look here. If I went back to my first grouping method, I said, let's go with this guy and this guy and this one. And then we had these ones right here, the singles. Okay, so what happens if we keep this like that, but change this one into 3 times, make it a group of 3, because I do have 3 groups there, and we make it 3 times, well, how do I have that group? That really is s minus 1. Does that change things up a little bit if we were to switch this part out for this part right here? Well, let's take a look. Let's go over here and let's plug that in. Let's do this expression. 3 times s plus 2 plus 3 times s minus 1. Okay, we said we're looking at 11. So we're going to do 3 times 11 plus 2 plus 3 times 11 minus 1. So we end up with 3 times 13 still over here, plus 3 times 11 minus 1 is going to be 10. So we have 39 plus 30, and that actually equals 69. So, interesting. What we can see is this. This solution matches this solution, but does not match this solution. Okay, so why do all this crazy stuff and have you wondering, well, what's the right answer? What's the right answer? Okay, great question. Well, I think the key is this. I wanted you to see that if you don't consider your extra ones as an actual group, like here, a group of 3, then you end up with a different solution because it means that your expression can't adjust for the next size. You see, that piece is not always just going to be adding 3 more. That's what we're saying with the first equation. We're just saying, oh, you only add 3 more, or maybe whatever the size is plus 1 more. It kind of works, but doesn't always work, okay? And so it's better to have a group that you're multiplying by so that it does match up a little bit better. Okay, it gets complicated, right? The groups get complicated. It depends on what you see, and that's kind of what we're looking at. So sometimes, if it's your first time watching videos of me, sometimes I do it a couple different ways because this is how math works. We want you to work through it. Let's look at F. Turn one of your expressions into an equation that you could use to find a figure size with 219 green tiles. All right, so let's take a look at our expression. We would say 3 times the size plus 2 plus 3, times the size minus 1 equals 219. Something just like that. Okay? And that works just fine. So that becomes one way of looking at that. Okay? Does that work? Seem to work okay. Seems to be all right. Yeah, we can say that's okay. Yeah. So that's one way of looking at it. Are there other possibilities, other ways to group this? There absolutely are other ways of grouping this. You totally could group it in some other ways, and that's okay. Another solution that I saw in kind of getting ready for this was 3 times the size plus 1 plus 3 times the size. Does that work? Sure, it works the same. You get the same solution, right? So it's just kind of up to you for what do you see. All right? And again, just different ways of approaching it. That's how math works sometimes, and especially when you're looking at these types of problems. Now, when you look at problems like the next group, a little different here. There's only going to be one solution. So here we go. So next section, we're going to be graphing the ordered pairs on the table with the points given. All right, so let's looking at number 9. The x value is going to be down here. This is our x, and this is our y. So the x, when x is 0, y is 4. So 1, 2, 3, 4. So our first point's right there at 0, 4. For 2, we're going to go 2, 8. That's 2. And we're 5, 6, 7, 8. So right there. Next one's at 3. So there's 3. And we're going to be at 10. The darker lines are the 5, so that goes there. And then we're at 5, which is here, and 14. Well, if this is 15, we'll come down 1 and put it right there. So those are our dots. If you want, I can make it a different color so you can see which ones I'm talking about. There, 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 and there. All right, so those are our points for that one there. Got the idea? All right, let's look at another one real quick. Our first point is at 0, 12. So we're going to start here at 0 and go up to 12. This is 10, 11, and here is 12. Our next one's at 4, which is here, and 8. So it's 5, 6, 7, 8 is right there. We have 7, which is here, and 5, which is the darker line. And then 9 and 3 right there. All right, and our last section here, we have 2 and 13, so it's 10, 11, 12, 13. We have 4 and 12, which is here. We have 6 and 11 there, and 8 and 10 on the line. And finally, we're going to do 1 and 6. Oops, sorry, that's 0 and 6. Be careful. We'll do 1 and 6 here, 2 and 9 there, 3 and 12, 11, 12 there, and 4 and 15 there. All right, that is really it for the day. Hope that helped you out a little bit, and we'll see you back here for the next lesson. Again, always do the homework, work it out, struggle through it a little bit, and then check your work with me to make sure you're getting the right idea. All right, that's it. Have a great day. We'll see you next time.